starting to the next presentation. It's a workshop on nano solar system, presented by two Gors and the sorry, there are 5 persons. So it's all of them from India.
Yes, currently Nishant Gor and Het Ahir are presenting. Other members are busy with some other stuff. So,
okay, then let's start.
Yeah.
The title is the first step to know about our home in universe.
Yes. So when we are talking about our solar system, so it is a very unique. This one is very unique way to introduce how big our universe is, and I think all the members who is attending this workshop are working in the field of popularizing astronomy and working with the astronomy awareness with all kind of students, all kind of public, general social public who are not involved in actively involved in this field. So I'm giving you a glimpse how can we teach people that this is one of the biggest world we are living in. If we go on a if we make solar system on a nano scale, how big it could be and how far we are going to see this at the end of our solar system. So now we are going to learn few things today. So this is the first workshop in our series of 3 years activities. So what is astronomy? First we will get that glimpse, then starry night. There is so many things talked in the previous sessions about starry night, Milky Way nights, then stars, what are the stars, the sun, and then we come to the point of solar system. So in solar system we have different elements, the moons, planets, dwarf planets, asteroids, comets, and so on. Then we will perform the activity of making our own nano solar system. So what astronomy is? Astronomy is a branch of a science which deals with celestial objects, space, and physical universe as a whole. So this is the general term of astronomy. The scientific study of the universe and of objects that exist naturally in the space, such as the moon, the sun, planets, stars. This is the definition given by Cambridge Dictionary. And NASA defines in a very simple way: the study of stars, planets, and space. That's the astronomy. So we have two kind of astronomers. One are observational astronomers, like we almost are doing, and the others are theoretical astronomers. They make models, they calculate all things, they analyze how these systems are evolved. So these are two basic parts of astronomers: observational and theoretical. Just like we also heard so many things about practical and general physics and theoretical physics. So these are the two kind of difference between observational astronomers who are also searching for the comets, who are also watching the sky, who are also popularizing science in the field in among the societies. So these are the basic difference in astronomy, theoretical astronomy, and observational astronomy. So starry night, we talked so many things about this topic in previous session, and one of the most beautiful thing is that so many people are thinking about this clear sky, the light pollution less sky. So when sun sets and day turns in the dark, you can see uncountable stars. And in that dark sky, we observe so many objects, some like bright, some are dull stars, some are eye-catching bright like Venus, or you can say Jupiter, like bright objects, to faint cotton ball type Andromeda or Orion Nebula kind of objects. So for all these things, we have to go to the actual really dark conditioned area where there is lesser light pollution and where we are able to see plenty of these beauty. So these all tiny dots are known as stars. So how many type of the stars are there? Types are protostar, main sequence star, as our sun is considering as a main sequence star. A red giant, white dwarf, red dwarf, neutron star, blue giant, supergiant, pulsars, and the list is going on. So these are the types of stars. So the stars are mostly easily recognizable objects, and these are the gaseous balls who illuminates themselves, and it is a fundamental block of the galaxies. So by introducing astronomy, introducing these kind of basics, we move to the structure of the stars. Here we have the structure of the sun, which has solar flares, and mostly we all are in current time afraid of corona, but sun has its own corona, and to see this corona through your eyes, you guys have to be at the point of a total solar eclipse totality line, and after that when the moon covers the whole sun, we are able to see the corona. And I'm lucky that I have observed 3 total solar eclipses, which was happening from India from 1995 to 2010. So here we are able to see the solar flares, coronal mass ejection, and core is the most hot point of the star. So when we talk about the sun is our main star. So mean distance is from Earth is 1 AU. If we go with the speed of light, we'll reach there in 8.8 minutes and 19 seconds. Just 8 minutes and we are reaching to the sun. But practically it is currently not possible to go at the speed of light. So sun, mostly all stars are recognized by 2 kind of magnitudes. The first one is a visual brightness, how you can see the star. So our sun's magnitude is -26 magnitude. And then what is absolute magnitude? So if we put any star at the certain distance of 32.6 light years, then that star, how bright it appears, and that is called as an absolute magnitude. So angular size of the sun in the sky is 31.6 degrees to 32.7 degrees. As in January, it is very close to the Earth, it appears on a bigger size, and in June, July, we are able to see smaller sized the sun. So distance from the Milky Way is 27,200 light years from the center of the Milky Way. So sun is one of the most important star for us. Because of sun we exist. So every civilization, as we talked about in the last session of Indian astronomy, there is immense different civilizations which are dedicated to the sun. So in Hindu civilization, it is called as a Surya. In Egypt, they call it as a Ra. In Japan, it is Amataresu. Correct me if my pronunciations are wrong. In German, it is called as a Sol, Solar, Sun. There is so many things we know about. Every culture is connected with the sun. So here is the sun. So there are so many phenomena we are able to see on the sun. So these are the highest solar spots, sunspots cycle of the sun. And these sunspots are so big that we are going to learn in our nano solar system practical. So, and when we talk about this, we are able to see a comet is approaching to the sun, and it will go and enter in the sun. And on the other side, it is just a gas released by. And here is the transit of Mercury happen on a happen in 2003. And after that, we have observed many transits, and after that, we are able to observe one of the most beautiful Venus transit in 2004 and 2012. So this is about sun. So few facts about that. I'm not going deep into that. That 1 million Earths could fit inside the sun. Sun contains 99.86 mass of the solar system. So when we go between students, we all we share these kind of facts about sun. Then almost perfect sphere of the sun or any kind of a star is a perfect sphere. Then eventually sun will consume the earth, and after that sun will be one of the size of our earth. So what will be the size of nanoscale earth and nanoscale sun? We are going to learn after that. So here is the solar system. How many parts of the solar system are there? The star is our sun, planets, dark planets, minor planets, natural satellites, asteroids, asteroid belt, comets, and list is so on. So this is the scale of our solar system. So here you are able, if you are able to see the laser pointer over here, we are somewhere over here. This is the limit of our human range, we can say. And power of the sun exists up to 1 light year, because Oort's cloud is there, and many planets are coming from there. So one star, 8 planets: Mercury, Venus, third one is our Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. 4 inner planets which are made of rocks, and 4 outer planets which are made of gaseous. There are natural satellites. These figures are of the data from 2016, so it can be plus or minus somewhere. So natural satellites are more than 450, which 175 are planetary satellites, and 297 are minor or dwarf planetary satellites. Now dwarf planets are few hundreds. The most famous is our Pluto, now which is not considered as a planet, but it is considered as a dwarf planet. Minor planets and non-comets. So this is the number from 2016, and after the almost 5 years, this number will be will have a huge jump due to technology. So the 4 smaller inner planets are known as a terrestrial planets, because they are made of rocks and metals, and the rest of 4 are known as gas giants. So what the distance they are situated, and they took the periodic time. So we are not going deep into that. You all might know all these things. So we are going rapidly. And now we are coming to the topic of nano solar system. So what is nanoscale? Nanoscale is 1 nanometer equals to 10 raised to 9 1 by 10 raised to 9 meters. So 0.9 ninth number will be the one in a meter, or we can say 0.12 zeros, and then 1 is kilometer, is 1 nanometer. Similarly, if we talk about light year, so we have to put 31 figures after the point, and that distance is called as a 1 nano light year. And then if we talk about astronomical unit, it will be around 10 zeros, 27 zeros after the point. So now when we are going to make the celestial nano solar system, we have to this follow this scale. We have to apply this nano scale to whatever figure we have, right? So now here we are going to make a nano solar system. Here at the background, you are able to see we have printed 139 centimeters sun, and on that we have put our all planetary bodies that we are observing through telescope or through naked eye on that particular scale. So it is time to build our own solar system that we are going to make over here. So first one will be the Mercury. So radius of the Mercury is 4,878 kilometers. But on nanoscale, they will be very smaller, around of a half centimeter. This is little bit bigger, so we are removing some material from that. And now again we are molding it, and you know it's if you are not able to see the graphs, please ping us so we can know that there is still more. So now I'm more removing the materials. So here is the
Gorat, I think it's better to once stop sharing. Then your camera is
yes, that's true. That's true. Yes. So here we have still more mass in this. So when we do these kind of activities with students, it is really fun that on this big sun we have presented right now in background of our photo, our screen. Here is the nanoscaled sun. Mercury will be this size of a tiny thing. Here is our Mercury, which is almost a little bit bigger than the measured size, but we can say yes, this is very close to it. Now after Mercury we will see the Venus. Venus will be of the size of 1.210 centimeter. So here we are going to make Venus. Venus is a bright white object, right? We are able to see as due to sulfuric acid clouds. So we are using white clay for to make the Venus, and it is still bigger. So we are going to remove this more clay from it. And now here is the size of Venus. And next will be our Earth. We are not going on a very precise scale, but here these all things are to understand how big and how giant our solar system is. So this is the planet Earth, almost same size of our Venus, because Venus diameter is 12,104 kilometers, where the Earth's radius is 12,756 kilometers. So here is the Earth, little bit bigger than the Venus. And now, which one will be the next? The Mars, the red planet. Now, red planet is of the
Nishant,
half
would
size
you
of
want,
Earth.
Nishant, would you want to bring the camera a bit, the screen a bit into the center? If
Yeah,
you want.
yeah,
Okay, great.
yeah. Thank you. Please notify me these kind of errors, because I'm putting camera downwards. So now we are making the red planet Mars, and the size of Mars is around 0.679 centimeter. So I'm going to remove all these extra material. And now here is the size of the Mars. And this is the nano sized Mars. But yes, we also forget about our moon, the closest companion. And closest companion moon will be made from the white and a little bit black clay to represent the colors of so here is I'm taking a little bit more white because it is very close and we are able to see very bright moon, and the size of the moon will be around 0.347 centimeters. Okay, so here is the moon, which is very close to our Earth. I think Mars is still bigger. Now, what is the size of Mars? 0.679. And here, so these are all our rocky planets, right? And now we are entering into the field of asteroid belt. After that, so we can put very tiny particles very in on this chart to show big rocks around us. And then it is a time to turn into a gaseous giants. So which one will be the first? Here we have almost 14 centimeter sized Jupiter. I have already measured this size, so I'm talking about it. If you want to make these kind of activities, you can use these kind of air balls, and by measuring this size, you can reduce the air pressure, and this ball will shrink up to what is your desired size. And after that, this is our Saturn. So Saturn is 12 centimeter radius, where Jupiter has 14 centimeter radius. So now, after that, we will move to the Uranus and Neptune. So size of Uranus is 5.112 centimeter. Which is this one, and this is 5 centimeter ball because I couldn't find the smaller one, and this represents 4.953 centimeters Neptune. So here we have built our solar system on a nanoscale. Now it is time to place this solar system on the field. Currently, we are not able to put all these things in the field, but we are going to see the scale of this distance between the sun and our nanosolar planets. So here is the sun. The sun is on the center of our solar system. So, and now we have printed these planets on the surface of the sun. Yes, so I'm giving Mercury to weight to compare the size of the sun on the level of Mercury. Yes, so you guys can do these kind of activities, that this big is the sun is, and the size of the Mercury is this, and what you have made is little bit bigger or little bit smaller than these appearances. So here is the Mercury, this small on a nanoscale. Then we are going on a Venus. It's almost same in the size. And now we are going to see the Earth. Is it clearly visible?
Sorry,
Okay.
once stopped sharing.
Okay, yeah, I forgot that. Okay, so here we have Earth in eighth hand, and here is the Venus. You see the apparent size if we put on these planets on our sun. So now here is the moon. Moon is little bit bigger than the nanoscale. So we can ask our students who are participating in this, that you made little bit bigger. Hit, can you resize it? Okay. So and I'm able to see that the Mars is also a little bit bigger. So I am resizing the Mars, and Hit is resizing the moon of our Earth. Yes, this is the size of. Still bigger. Okay, so just imagine that we are watching the moon is so big, so bright, which is almost 4 lakh kilometers. Yes. Okay. So what will be the size of the moon? Let me show it to closer to the camera. It's also hard to handle. Yes, this tiny ball is our sun, our moon on the nanoscale. And now we are moving to the Mars. Here is the size of Mars. Bigger. Yeah, Mars is also bigger, so you can reduce it. But now we are moving towards the Jupiter. So Jupiter is a little bit bigger one, and it can be easily handled. So, yes, thank you for the Mars. Yes, yes, this is the size of Jupiter. Then the Saturn without rings. And here is the Uranus and the Neptune. So this is the small scale, nanoscale solar system for us. We have compared the sizes, and now we have to put all these on our solar system. That's very interesting idea to make them with heatable materials. And yes, we are going to share that too. Now I'm going to share the screen again to see the distance between all these planets on a nanoscale. So here is in this first column, we have actual distance in this column, where we have taken the distance from of the moon is from Earth. So when we put our sun at a zero distance, our nanoscaled mercury here can be placed at the distance of 58 meters. Then Venus will be at 108 meters. The Earth will be at 150 meters. And most of schools has the limit of Earth, because we can say this is the bigger than our football ground. So biggest ground can be measured in a nanoscale is distance between Earth to Sun, and here at a very small distance, 0.04 meter, means 4 centimeter away, we have to put our moon. And the surprising thing with this nano-scaled solar system, if we watch the sun in the sky, and if we watch the nano-scaled sun from the distance of 150 meters, then the size of these both sun will exactly appear same as the actual sun is in the sky. So this is the test of accuracy, that how accurate we are going. If the sun is appear bigger or smaller, then our scale might be in might be with some error. So for that, we also can give students that activity, that now you have to correct what is the actual distance of sun and earth. So when we observe these kind of activities, students will do the correction activity with the reference of earth. When the earth is closest to a point to the sun will appear, the natural sun will appear big. And if we are in a June-July month, the sun will appear smaller than we are watching the nano sun. So they have to adjust themselves to find what is the position of earth in the reference of sun. After that, 228 meters, we have Mars. We have Jupiter at 778 meters. Saturn is 1 kilometer and 429 meters away. Uranus will be 2 kilometers and 870 meters. Means almost 3 kilometers away from our nano sun. And the Neptune will be 4.5 kilometers away. So when we teach these, we perform with students all these activities, they just imagine what this much big is our solar system, and we are living on this tiny ball and fighting for a few small part of land or a few rupees. What is our existence in this universe? What is what these kind of things, why we are fighting to each other to conquer only this particle, like a dust like particle in the terms of universe? And we can extend this model up to 1 light year to show how far our Oort's cloud is there. Then we can place some Voyager 1 or 2 yeah, or a Pioneer 9 or 10 spaceships which travel up to 20 light hours away, 21 light hours away. So these all things can be uh, first seek to understand the size and the equation of the universe, that how big our universe is, how big our solar system is, how tiny the humans are. But the one most important thing, humans can be tiny or just a scratch of the universe, but the thought of the human, thought of a mankind, thought of these two-handed, two legs, and one-headed species are so big that they are measuring the whole universe. They are measuring, they are trying to understand, they are trying to find the origin of their self and universe itself. So if you guys have any questions, you have queries, you can share. And yes, I forgot one more thing, that generally we ask students to find the naturally what natural sized equipment find for all these kind of planetary system, like we have done with this seeds. These are the eatable materials. This is very close to the size of Venus. This is very close to the size of Moon. Here I have a few ball bearings which are the size of the Mercury. I have few marbles. This is this is the size of the Venus, and this is the size of the Earth. So we also give activities to find the most supportive size things around the location where we are performing nano solar system activities. And as in comment we have shared, so if they are so mesmerized that we are not able to find the smallest size thing which fits in our solar system, or we are not able to find a perfect sized thing around us. And we also keep balloons. So here I'm making a Jupiter. Yeah, here is the size of Jupiter. And it is a gas giant, and that's why we are using the balloon. So here is the size of Jupiter, and better size. Yeah. So now we can adjust by so these kind of activities can be performed by students, and they can make their own nanoscale solar system, and they can understand that how big our universe is. So this is our workshop, this is our activity for now, and we can we go to the question and answer session, or if anyone have any implementation in this model, they can share their experience with us. I think you all have enjoyed this activity. Thank you everyone for providing opportunity. GHOU, Global Hands-on Universe, Manthan, Stargazing India, and everyone who is around here. Dr. Bandari sir, Dr. Adure sir, these all are our respected teachers. and from these teachers, we all learn these kind of activities. Thank you everyone for appreciating it. So that's it for from our side. If you have any questions, we can like to share our experience with that.
Okay, thank you very much. And any questions or comments? There are several comments already typed in chat field. But anyone has any oral question or comment?
Yes, Handa sir said that nano solar system can be mapped on a biggest cities, like when we are going on the scale of light years. So how big we have to go?
that is the overseas.
Yes.
Maybe farther than between Japan and India.
Yeah.
But the nanoscale solar system is quite suitable for the large cities.
Yes.
Yeah. So in Japan, we the scaled model, the slightly different scale. It's a factor 1.3 is difference, but the order is the same. So we put the mark. That is a stamping point all over the city, and so but the planet size is we are just only posted the figures, the image, not only the ball.
Yeah.
So the combination of them
we are actually planning in our Kutch district that we have few kilometers straight road without any curve. So we are going to put our nano sun is there, and then on a several distance we are going to put all planets up to Neptune and Pluto.
And so for example, as the classroom activity, then how about to take the photo by him or herself by selfie,
Yeah.
occasional in the city.
Yes.
From the school. That is an idea.
Yeah.
Toshiro, I remember this thing when you were presenting this project almost like in 2009 when I met you for the first time. You had been carrying out this thing in different shops of your place, right?
Yes.
Yes.
I think that's a brilliant idea. And
these are the cue words from that time.
So I also feel, Nishant, you have a white run of Kutch. Is it like a span of four
Yes,
kilometers
yes,
or something?
yes.
So I think that's a very beautiful place to utilize for such a nano solar system. And I think it's brilliant to use there, because it would also be a tourist attraction. Just for a thought.
Agree. We are going to do it near Tropic of Cancer. So
Great.
Tropic of Cancer is passing from just 25 kilometers from our city, and we are going to plan something around that region.
Wonderful. It was a wonderful presentation. Loved seeing it.
Thank you, Gautam sir.
And from your presentation, I have an idea. So the made small planets by eatable material.
Yes.
And they combined with our activity in Japan. So I propose to make some chocolates or beans by the sweets shop, and they provided. This is the same size Jupiter. It's a large cake.
Yes. Oh,
I will propose to the sweet shop.
Yeah. When any kid's birthday is going to be celebrated in this way, the astronomy is already seeded in that way.
Hmm. So, anyone has any comment? It's a very interesting and enjoyable activity.
So
Okay.
meet our next generation astronomer, Vigyan.
Yeah.
She's my daughter. And with one younger brother. So they both are also taking interest in all these kind of things. So she came from the study that I want to see this activity, how you are presenting and what's going on.
Nishant bhai, it's the third generation who will be coming in, right?
Yes.
Your father was also involved in the same thing.
Ji.
So it's good to see the three generations coming in. Wonderful.
So I would like to invite everyone to the land of Kutch, where we are doing all these kind of activities with tourists, as you have seen in a astro-tourism workshop presentation. Then we are working on local astronomy, as you have enjoyed in eighth presentation as Indian astronomy. And there are so many other activities, astrophotography, astro tours. So you all are welcome to our mystic land of Kutch. And I'm also inviting all of the organizations to meet hand with us and help in develop astronomy among all of the world's region and make a strong bond between different locations. As my father started the first project of star peace in India and Pakistan, we can global hands-on universe can start this kind of project on a global level.
Okay. So, any other comments or questions? No. Then okay. Thank you very much for nice activity. That we hope to many people do the same thing or improved one and exchange the improved idea. That is a very important point of the presentation through the international workshop.
Thank you, everyone.
Thank you very much. So we have say 15-minute break, and we meet again in the same workshop room. It's 5:15 in UTC. Okay. Okay. See you in 15 minutes later.
Amritanshu, I think the sharing option has been provided to you.
Thank
So
you.
after this, you can try to do
Thanks
that.
a lot, Katan sir. So all the panelists have joined. Narendra sir is there and Adur sir is also there. And I will be sharing on behalf of Adur sir.
Okay.
And if Bhandari sir's PPT is also with me, if any problem comes, I will share from my end. Up till now, Bhandari sir himself is sharing.
Okay. Aviva, I would also request to give access to Bhandari sir for sharing. Thank you.
Welcome, sir.
Sure.